device is also good. They will all calculate the topology by themselves. That is, dynamic routing protocols are essentially loop-free, because they need to understand the information in the network. You will learn topology drawing later. When the information in the network is drawn, these network devices, how to connect each device after receiving the information, they can be calculated by themselves. After the calculation, it can know whether there is a loop in the network, and has its own some anti-ring means, based on different mechanisms. But we won't talk so deeply at this stage, so everyone understands that it is acyclic. That is, for each dynamic routing protocol, you don't even have to worry about loops, unless you have some redundant configuration. For example, you configure a virtual connection for OSPF. This may create a loop, but we will not at this stage. That is, if you don't configure it normally, do not do those configurations that make it cause a loop. It won't have a loop. We won't talk about the trigger update later, because when I talk about appearances, we'll tell you about this. Let's look down. Here is an equivalent load balancer and non-equivalent load balancing. In fact, the balance is not appropriate. In fact, it is more accurate to say that load sharing, because it can't achieve true balance. The traffic will still be worse. But let's just say, do equivalent load and non-equivalent load. What does it mean? This has to be a separate picture. Okay. Let's take a look. For example, now here is a device. There is also a device here. There is also a device above. There is also a device below. This is R1. There is a route on the right. It is on the 1.1 network segment. For example, after I run EIGRP. So now R1 can learn this route from both above and below. Then according to the routing table addition principle, under the same agreement, we start by comparing the routing metrics. Whoever has the smaller value will be added to the routing table, if the measure is the same. For example, above is 1000. Below is also 1000. Of course it's usually not that small. Wait a minute, we'll look at the specific parameters. Then they will all be added to the routing table. Since they are equivalent, we call this table addition equivalent load sharing. Then there is another situation. If the measure is different, we call it non-equivalent load sharing. But you may find it a bit strange. If the measure is different, isn't it possible to add the smaller metric value to the routing table? Shouldn't the ones with larger metric values be added to the routing table? But EIGRP is different. EIGRP can use some special methods. Let both appear in the routing table at the same time. If I change it to 10,000 above, the following is still 1000. These two items can be added at the same time. But the following one is better. The above one is worse. Unequal load sharing. I can have them appear in the routing table at the same time. How to do it we will see today. Of course, today we will show you the contents of the topology table. Let's talk about this when the time comes. Just know that it has such a mechanism. Actually not very common. Let's go on. Flexible networking design. It is to update later. It is for network equipment. No restrictions. Not like RIP. Finally, talk about this multicast and unicast. For multicast, first of all, EIGRP uses multicast for our overall data interaction uses multicast. Then for RIP version 1 uses broadcasting. Bad radio. I simply draw a picture to explain. For example, now this device Run RIP. For RIP. When the information is updated. Suppose there is a switch in the middle. A PC is connected here. It's okay. 2 routers connected to one switch. There is also a PC connected to this switch. Then if RIP is delivered through a broadcast form. When the two of them are exchanging information. PC can also receive this data. That's the bad thing about broadcasting. It is not necessary to receive this data. Secondly, now they are exchanging routing table. It acts as a PC. What if it's an attacker? The data of the device is broadcast to the PC in this way. It's for us. The privacy and security of the network is also not guaranteed. So broadcasting updates is not a very good approach. For unicast. You can't see it in EIGRP. You have to be inside OSPF to see it. You will learn the NP stage in the future. When learning OSPF, you will learn about a network called NBMA. Under this type of network, it communicates overall via unicast. But we can't reach it at this stage. Of course, OSPF still uses multicast more. Same as EIGRP. This is the communication between them. How to understand this multicast? In fact, I told you briefly before. Multicast is. These devices can be added to the group before communication. So how do we define multicast when we run EIGRP? Is that you have EIGRP running on the device. And after the declaration is completed, the group will be added automatically. This is called protocol-based grouping. It is added automatically. What's the benefit of this grouping? Is equivalent to. You can listen to an address of this multicast once. I will send some information in the future. Send to such a logical multicast address. As long as the device is added to this group, I can monitor the contents of this address. Then I can receive the data. This is what we call multicast. You will learn about the specific content of multicast in IE. Like WeChat group chat. You want to message someone right now. You have several ways. For example, private chat 1-by-1. You can also choose. Pull these people into a group. Then talk to all of them. Then some students may ask. What is the difference between broadcasting and it? Give another example. For example, your company has about 100 people. You have a WeChat group. Suppose there are 20 people in your department. You have a better relationship. You have a separate group chat. This is your group. For broadcasting, it means you are within the scope of your company. You send a data that everyone can hear. But sometimes, you just want these 20 people to listen. You have a small channel. This is called multicast. If you want to send data to others alone in the future, sending 1-by-1 is called unicast. Look down. Support VLSM. We still have to draw a simple picture. Don't look at it just a few words. There are a lot of things involved. A PC. 2 routers. This router has a network segment here. Suppose this network segment is 172.16.1.0. 24-bit mask. Okay. It is clear. This is a Class B address. No matter what the bar 24 behind it is. It must be subnet. Otherwise, according to the rules, it starts with 172.16. Should be a 16-bit mask. This is a standard Class B address.